There we go. Perfect. So we are talking about the use cases of coprocessors today. Just a sign of hands. Who has been at the encryption day at EFCC? Okay, 2, 3, 4. Okay. Who understands and who knows what a coprocessor is? Just a sign of hands. Okay, so around 20%. Okay, so maybe let's start out with Guy. Can you explain in easy words what a coprocessor is?
A coprocessor, the way I like to describe it is basically some supposedly off-chain process that kind of helps you run like computations that are maybe longer or need some other properties that you can't really run on-chain. But the critical difference, I mean, this is not an oracle or an off-chain system. The critical difference is that it has to have the same security properties as the chain it is linked to. So a good analogy to think about it is, the main chain, the L1 that it's connected to, or the L2 that it's connected to, is basically like the CPU. And this might be like a GPU that does better, like, AI computations or graphic computations, so that the GPU in this case is like a coprocessor, and they both kind of have like the same security properties in crypto.
Okay, perfect. So just as a round of introductions, maybe starting with Stephen, can you briefly introduce Risc Zero and what's happened in the past 6 months, especially on the coprocessor side, and then Mo and Guy, please go after.
Yeah, hey everyone, Steven from Risc Zero. I work as the head of strategy. At Risc Zero, we're building a general purpose ZK virtual machine. So this basically lets you prove any sort of computation, mainly written in Rust. Over the past 6 months, I think we've seen a lot of additional traction in the ZK coprocessor space. Really 2 things have enabled that. One, we finally finished all of our audits of our ZK VM, so it's in 1.0. And then also the performance has just got there. Doing really intense computation in the ZK VM is really feasible right now. There are multiple teams building on us that are doing computations that basically would have cost 8 million, 10 million gas previously, that can now be done in the ZK VM for a few dollars of proving instead of like thousands of dollars of gas.
Awesome. Mo?
Hi, this is Michael from Brevis. So what we work on is also a off-chain verifiable computing platform. What Guy mentioned is that for coprocessor, the idea is to offload some type of computation off-chain. So that's the first part. Now, what we work on is a ZK-powered off-chain computing. What that means is that when you generate the computation result in an off-chain environment, you're not just doing the computation itself. A ZK proof to attest that the computation is done correctly. It's also generated at the same time in this very low unit cost environment. And together with the initial result, you can submit the result back to the blockchain. And the verification process on blockchain for that proof is very simple. So the blockchain in that way can directly consume the computation result as if the entire computation happened on the blockchain itself. Right, so there are many different types of computation we can target on. Like for example, Risc Zero starts with very generalized computing, but for us, we choose a very specific trade-off point to operate on, which is targeting initially the capability to allow smart contract to have access to historical on-chain data such as transactions, events, and states. So once a smart contract have access to these kind of data, they can build very powerful data-driven, complex computation-driven features to dynamically change their protocol behavior to offer new type of experiences. So in the last 6 months, what we really kind of experienced is the explosion of use cases. Now we have like 18 different partners and use cases building out Brevis, and we'll be launching, many of them will be launching in the next month or 2. So that's kind of the things we are very excited about.
Yeah, so I'm Guy. I'm a founder of Fhenix. I'm, I guess, mostly a researcher by training in MPC and lately in FHE. Look, what we're building at Fhenix is essentially a layer 2 that allows you to run basically Solidity contracts, but in fully homomorphic encryption. So you can basically run private computations over encrypted data. The way it ties into coprocessors is that we basically take our L2, we wrap it into a coprocessor. That's a technical part, but the goal is really to be able to put like Phenix at every L1, like on Ethereum, on Arbitrum, on Optimism, wherever it is, and allow anyone, any app developer, to basically utilize like sensitive data and private data whenever they need. This is somewhat, our goal is, there's some overlap, but our goal is slightly different than, I guess, my other two co-panelists, which are more interested in kind of like proving, doing heavy off-chain computation and then proving correctness for security. In our case, we really want to allow people to do new kind of applications that require sensitive data. So to give an example, like, you're lending on, let's say it's Aave, right? And Aave right now, they have no idea who you are. So they give like the same rate of like funding, like you get the same, like you can borrow the same amount regardless of who you are, because there's no concept of identity, and obviously that's a very, very private thing. So maybe they can use like our coprocessor. All good? Yeah. So maybe they can use our coprocessor to go off-chain, compute someone's like credit score based on like some data that they share encrypted, so no one sees it, not us, not Aave, not anyone. But then Aave can give them on-chain like better rates of funding, for example.
Okay, perfect. So I think when we look at the coprocessor space, I think one of the big questions has always been, what are the use cases, right? When we look back a couple of years ago in CK, the key question was, what are the use cases? And I think in the last 6 months, there has been significant progress and process. So I would love to understand from each of you, what is your favorite use case of coprocessor? Maybe you can highlight a project that you're collaborating with, that's building on your platform. Maybe let's talk briefly about a specific use case.
Yeah, I can go first. By far, like one of my most favorite projects is this team called Hashflow, and they're building this thing called a provable exchange. And what they've basically done is they're running an order book, in some ways fully centralized. What that means for the users is basically it's Binance, right? Sub-second order matching, gasless bids and asks. But all the bids and asks, as well as the order matching engine, are processed through the ZK VM and proven. So what you get there is you get the verifiability that everything the order book did was fair. So basically like an FTX cannot happen. And then this proof is used and submitted onto Ethereum to enable deposits and withdrawals. So for the user, what the UX will look like is you're basically trading using your Ethereum L1 liquidity or Arbitrum or Solana or whatever. You can deposit anywhere. And then your bids and asks are fully gasless. And then everything is generally cryptographically secured. So it's really exciting because you basically get a dApp with Binance sort of UX and also this trustlessness that no exchange has. And another like really important piece there is because these coprocessors are written in Rust, for developers, they have substantially better expressivity. Like that you can just like fork an order matching engine on built in Rust on GitHub. It really doesn't require much additional complexity, which is something that application developers had to wrestle with basically for the past 5 years in EVM.
Awesome.
Yeah, so for Brevis, like again, we very much focus on the functionality to allow smart contract to have access and compute on historical on-chain data. So what that capability enables are really kind of 3 categories of use cases. The first category, which we are very excited about, is something called intelligent DeFi. Now, what that means is that it allows you to now, now DeFi project that can dynamically change the protocol parameters on a per user basis or on the protocol level based on the historical behavior of their user groups or the historical condition of the market. What that means, well, the simplest example that I can think of is trading volume-based fee discount or trading volume-based fee tiering. This kind of feature exists in every centralized exchange. If you look at Binance, Coinbase, every single one have them because they work. And if you look at all the DEXs, none of the DEX have this kind of feature. Why? Because accessing historical data to generate a computing result of users' historical trading volume is impossible today on chain. And Brevis enables that. Now we work with folks like a lot of DEXs like PancakeSwap, QuickSwap, Thena, Kim, a lot of them actually to enable exactly this feature so that the user have very good experience. And Brevis is really production ready in the sense that we actually launched in mainnet an in production feature with a perpetual swap protocol called Quanta, who is now being acquired by Synthetics actually. So we launched a VIP trader reward program that boosted the volume of the trading volume for Optimism by about 5 times, like by just launching this feature, because now market maker can have better market structure provided for this entire stack. Now the second, I'll quickly touch on one second, is like a second category, which is more towards the mass adoption and user-facing feature, which is token drops. Like, how do you distribute token? It's the most important question for every single blockchain project, right? So, but today the token distribution process is very broken. Like say, it's based on one-off airdrop. It's black box for user, cause frustration, and a cost center for project. We work with a project called Euro, which today announced their Binance listing. Congratulations to them. And to enable this kind of a new type of continuous protocol incentivization to allow users to continuously prove to the blockchain their interaction and contribution to the token ecosystem and to the protocol ecosystem, and use that as an entirely trust-free and decentralized way to actually mint tokens directly out of kind of a contract. So that is a new way, entirely new way to distribute tokens. And this is something that we're super excited about, that it's going to launch in the next 2 weeks.
Awesome.
What's the name of that project?
Euro.
Euro?
Euro, like Euro, USUAL, I think. That's the name of the.
That's an interesting concept.
Yeah.
I'll give 2, one which I mentioned. There's different use cases I'm excited about, but these are focused on the coprocessor. The first one is really, I think we're at the point where getting on-chain identity is interesting. I used to be bullish and then bearish, and I'm bullish again about that. And the reason is that many more smart wallets are emerging, where people are, connecting with their social profiles, like Twitter, like GitHub and others. And that source of information is extremely useful to kind of build something like a reputation score. Again, maybe for airdrops, maybe for giving you better liquidity terms. And with the coprocessor, right, then any application anywhere on any chain, they can kind of subsume it and reward users that are higher tier than others. And obviously this needs to be done privately, right? You can't actually link on chain people's real identities with their pseudonyms. That's a really bad idea. So what we have, using an FHE coprocessor really solves that. So that's number one. Number 2 is a project we're working on. So what they want to do is basically build dark pools. Dark pools are prevalent very much in the TradFi ecosystem. They have not really succeeded as much in the crypto space, and one of the reasons, or maybe the only reason, is a lack of privacy, in the matching and so forth. And so they want to use our coprocessor. Basically, they want to go to the chains with the most liquidity and basically put that dark pool exchange there, and all the logic will be going through our coprocessor. So, another great example, I think.
Awesome. So when we look at the coprocessor industry, what is missing as a next step? Is education missing? Is DevRel missing? Is marketing missing? What's missing to onboard? Well, I wouldn't want to say the next billion users, but let's say the next 100 million users.
I want to start, if that's okay.
Of course.
And the reason is because I hope they have a better answer, because that's something that we debate internally a lot. So I think one glaring problem maybe that people don't talk enough when it comes to coprocessors is that they change the computing paradigm of a smart contract. So until today, when you write a smart contract, it's basically like writing a backend program. You write a program that's synchronous, it has functions, it runs. When you call a function, it runs from start to end, and that's it, and you get a result. With a coprocessor, now you have this asynchronous process. You call a function, that function has to trigger some other coprocessor process, which doesn't happen on chain, and then it has to do a callback to the chain which you kind of need to listen to and then handle. So it's a different paradigm for developers, and I'm frankly a bit concerned about what that's going to mean for user experience and dev experience, and how comfortable developers are with that. I don't know if others have answers about that, but that's a point of concern.
Well, I cannot agree with you more. So yeah, absolutely, it changes like the development paradigm for sure. Just to kind of build on top of what you just said, like the bright side of this is that we had this problem before. So we had this problem in Web 2. Back in early 2000, the entire Web 2 architecture is also built in a monolithic synchronous architecture, where you have a web server that does everything. Like, every user come to the web server, it go hit to the web server. The web server does database lookup, read, write, everything. So that was not scalable. So this is why, in modern web architecture, if you look at the entire Google's entire web architecture, they introduced this concept of asynchronous web architecture, where you have a web front end, like this is not just kind of the user front end, it's like the web backend's front end, as a thin layer that is just a glue that can glue multiple different specialized coprocessor backend services together. Now, under this architecture, we also had the same problem of asynchronous design pattern. But the good thing that in Web 2, we solved this by having awesome developer tooling to hide and abstract away the fact that we're communicating between different service pieces. And I think the same thing is going to happen in coprocessor, for ZK coprocessor and many other coprocessor in blockchain space as well. I'm seeing, and we are doing this actually rapidly, that new kind of a developer tooling that is available, scaffolding on chain that is available to mitigate and hide away this type of a new complexity is introduced by the coprocessor architecture.
Stephen?
Yeah, I think once again, I agree with what everyone said. Really, for us, what we've been thinking about is like, how do we make people really understand and feel why coprocessors are cool, right? What's very clear here is it's a very different architecture, and it's a fundamental change in how people think about things. And if I look back in crypto, like rollups weren't that popular until OP and Arbitrum came around, or Solana wasn't that popular until you had pump.fun come around this cycle. Like, people really need to understand why this tech is useful, why you need like the capabilities of SVM and Solana to actually be excited to build on it. And if you were to ask us right now, like, is there one really exciting use case or project that's building on a coprocessor that everyone knows, the answer would be no. But when that comes around, and we're incubating, all the projects here are incubating a lot of exciting teams building on this. When that comes around and people can finally feel what coprocessors can do, I think that's when we're going to see an explosion in developers.
Perfect. I think we run out of time. Just very briefly, if you're a dev, really check out coprocessors. I think it's really a new compute paradigm, and there is a lot of improvement to on-chain operations that can be done. Thank you to the panelists, and if you have questions, please grab us afterwards.
Thank you, everyone. Next up, we have Ingo Yama, My Network.